Okay, so we try to be concise and effective as well. So this is an ongoing paper. We show some preliminary results today, very preliminary results. We are working over summer to have a paper by the end of the year, maybe. This is a paper co-authored with Antonio MUSOLESI. So it's economic policy, econometrics type of paper, and we are pretty happy and we are also enjoying, I think, sincerely. So some background research and facts, and so there is a background paper, and just to highlight, some keywords. And we worked on Kuznets curves some years ago, and where the focus was on nonlinearities, heterogeneity, and also shock effects. Also another paper about shocks. So the idea is to, again, I don't want to repeat, but to relax some assumptions, provide a more flexible environment for the analysis. Okay. Given that the word is very nice, you need the report on innovation. Environmental performances, as you see, historically speaking, the trends are highly non-linear. Okay, CO2 policy innovations, you may have shocks, nonlinearities, heterogeneous effects, and so on and so forth. Another background paper is this one by Antonio and co-authors on knowledge. Our paper is on green knowledge. Inventions, namely, so patents, given that we are working at macroeconomic level. Okay. I'm going to skip, all the details about the data sets now. It's about the green patents, policy indicators. I just want to thank the SEEDS team, Nicola, Marianna, who are not here, but for the creation of some data sets, because it's and we could also share if you want. Another background is there is a very famous paper by John List using similar related regressions models on the US, and where the keyword is, does one size fit all, or we have heterogeneous effects. So we have even in a simple parametric panel data framework, you have some models like the SURE that may, among others, provide. Also a paper with Giovanni Marin, we published some years ago. Conceptually speaking, the role of innovation, I want to, I take it for granted, so I really, innovation is just there. Doesn't work. So. Was working with you. Okay. Yeah. Okay, it's working. So innovation is basically here technology knowledge is what we need to compensate for the scale effect. And so we have the role of policies. I don't have to teach you because as policies address to market failures at least. So that's why environmental policies have increased over time. Stringency, other features. Okay, for example, we have some papers about UTS, and there was a strong increase over the recent years. But again, even here we have shocks, spikes, up and downs. So that also in this way, it's maybe relevant to think about it. We have strong heterogeneity about R&D as well, even within the U, which is a problem of the U. So South Korea is up there. So again, you see the variation in the main input of inventions. So policies, heterogeneous, R&D heterogeneous, spillovers. So it's something that's a background. Hints for a macroeconomic oriented agenda. Why? First, because we want to say something more compared to the literature. So there are very nice papers in top journals by top guys, and just to mention a few in Journal of Political Economy. The tendency is to have a micro approach. Okay, so that's even in DTS literature there are several studies which test ETS, non-ETS firms, defects of innovation. So we want to our interest is more on the macro side. Okay, and where maybe there are some gaps or more. Don't know why, but okay. Some real new paper just for the students, for example. The literature is evolving. This paper by a theme working paper by Nesta Verdolini and Vona, another interesting one on the US by David Popp and others on spillovers. There's also a survey, a very recent survey by Popp on innovation, which provides a literature survey over the last 10 years, and also research highlights is MBR paper. Okay, so the research issues we have are in which way inventions, inputs generate green knowledge, taking into account the factors you see, and the other point introducing environmental policies in this version in a discrete way, just 0-1, so it's allowing for heterogeneous policy effects. So okay, so the data, as I said, we're also happy to share for joint papers. The green patents here I'm really skipping because the green patents Nicola is and Francesco are the expert. The policy indicators is our policy indicator we created out of OECD sources, and the different indicator from the OECD one. So we have an indicator ranging over different categories, and we are using in different papers. It is inspired by this gene paper by Francesco Nicoli, Vaughan, and others. So it's a kind of categories. Okay, so it's in this paper we exploit the binary version and to mitigate complexity also for the few observations and other reasons. I stress that this policy indicator is varying across time and over time and across countries. Okay. So econometric issues, inefficiency and biases, which is the general point. So we start with this type of specification where we have environmental policy, R&D, human capital, and spillovers. Okay. I'm focusing more, given my expertise on the economic interpretation now than. So we have, again, in terms of econometric background, various streams of literature which address heterogeneous effects, relax some assumptions about even additivity and other types of. So modeling, okay. The typical bias efficiency trade-off is arising when you compare parsimonious and complex models. Okay, so the typical approach is to use a known data generation process, and then estimate the model, robustness checks, and so on and so forth. In this case, we tend to compare different specifications, alternative, and to let data talk. Say so, we end up with some kind of selection without imposing ex ante. Okay. So results. So again, we're talking about green knowledge creation driven by R&D, spillovers, human capital, and policies. So that's the very simple framework. So result one, we have a rejection of linearity, and most important, we talked a lot about it. This individual trend specification beats the others. So we have a model where again we have green knowledge, environmental policies, R&D, human capital, and this is the preferred. Going to the highlights, individual time trends, which were also present in the Kuznets curve I presented that we published. Just to stress that individual time trends are one option among others, and they are a compromise between simple time dummies and multi-factor models. Okay, so again, you have this trade-off, which is one of the messages that we want to provide between specific models, general models, and all the pros and cons that you have to deal with it. Okay, so the chosen model at the end is a compromise between a very general, unfeasible model and very restrictive ones. So the idea is that you can play and select in data talk and end up with mixed models with different features. Okay, that may change case by case, innovation by innovation. The policy fact, it could be also an economic policy paper. So we have, I mean, the policy dummy is significant, but I'm going back to two policies in the final slides. To stress this, in the non-parametric part, you see the effect, for example, of R&D. Human capital, R&D spillovers, and when you have density of data, the issue is that that you see significant effects with threshold effects and nonlinearities. So this is the interpretation of reality. Okay, so it's another way of looking at data. Maybe my opinion is that this may be to some extent more effective. For interdisciplinary frameworks or for policymakers compared to asterisks and in tables. Okay, but this means a way that where you can see the effect of R&D on green knowledge or human capital, okay, or spillovers. Okay, you see that's. You may also interpret in terms of elasticities. So that's. So policies, and in this paper, very preliminary, we took one policies, as I mentioned, air pollution policies. We also have climate change policies and other indicators to play with. So we have a significant effect of policies, and the covariates are associated to significant nonlinear functions. Okay, so that's maybe the first message so far. Second point, and I finish with it. We are trying to model policies in this way, so to look at whether policies may change. Basically, we have the mean effect of the policy and the component, which is the influence of other factors on the policies. I mean, to analyze the possible joint structure. Okay, so again, this additive structure is which is one of the assumptions that we usually have, is rejected, and we play with this function here now. And two slides and I mean two figures and some comments. So again, the policy effect seems to be significant. So the average is positive and highly significant. And then we have that the effect of the policy appears to increase with both R&D and, sorry, it's a typo here. It's not human capital, is with R&D and R&D spillovers, sorry. So it's not human capital, but R&D spillovers, okay. While other couples, other variables are not emerging as relevant here for the green inventions. How it appears like that, you have yes R&D and R&D spillovers. So this is the way you represent this part here. Okay, so that's so you can see that you have in the fact is significant when you move when you increase both. Okay, this is a kind of joint effect of those two terms, which in another way is basically this type of effect. Again, you have R&D spillovers. Okay, so this is the function from another angle, I would say. Okay, it's the same picture but from another angle. Okay, so that's so again, this is really preliminary. We wanted to provide some figures for this seminar. Then we are working on it. So using this flexible framework, we find that policies are relevant to explain green knowledge, which is a trivial result maybe, but the methodological background is not trivial in the sense that you reach this result along a different line of reasoning, and then maybe more original the fact that you have heterogeneous policy facts, and policies are a function of features and contents that are country specific and have different trends over time as well. Okay, so that's the economic interpretation of a pretty complex methodological background, and we are working towards results here. And this, and I don't know if you recall Pitfall. This is in the 80s. To interpretation, yes, the econometrician is eaten by the crocodile, and or the econometrician is going to eat the economist, being the crocodile. I don't know. So then that's okay. Thank you for listening.
Questions? Just a clarification on the interpretation, because when you say that I have seen the nonlinear patterns that you show in the graphs, so when you say that critical mass is needed, do you mean that policy is ineffective if there is not already enough human capital or R&D, or that policy should be sufficiently strong to, because I didn't fully get what is on the horizontal axis of the graph.
Thank you very much, because I was running a bit due to time constraint. I guess the first one. So the policy fact is needs a framework or a situation in which is dense of in this case R&D and
No, the non-linear ones, the 2D-dimensional ones.
okay, the other ones.
Yeah, what is there on the horizontal axis? Sorry, so this is the link between
and knowledge here. Sorry. So in this case, this is the effect of covariates on green knowledge, I mean green patterns. Yeah. So that's.
Okay, so this means that if you introduce an environmental policy in a realm where there is not enough R&D, you will not get more R&D, basically. I'm simplifying, of course. No, yeah, but I was commenting on the final result about the critical mass.
So you jump from one to the other.
No, yeah, no, I'm trying to interpret them
No,
the
okay.
same sentence. That's
You have two different models. I mean, here policy is just a discrete indicator, which is significant. Okay, and then you have the covariates effects. Okay, so you have policies, which is a dummy, and then the covariates effects that you find here, which are non-linear and with thresholds. Basically, this is a message. Okay, and when we extend the model. And this is the policy specification, the policy fact. It's, I think, right what you said. So you have the average effect, and then it seems that a situation, a framework where the density of R&D and these spillovers is stronger. So the policy.
This is interesting because it suggests that environmental policy in itself is not enough.
Yeah. Yeah. Yeah.
One clarification. How do you measure WRD, which is a spillover?
Okay, that's for Antonio.
Okay. So my question is the following. In this case, I'm just trying to interpret as Alessio. You say that you need to invest in R&D in country I, but also other countries must invest to have a policy efficacy. So you need a cooperation across countries, among countries, to get effectiveness of a policy intervention. Is it correct, my interpretation, or not?
Yeah, I mean, the technology and knowledge embodied in trade and exchanges, maybe another proxy, but yeah, you need to be connected and to.
Since you need to have higher R&D and higher WRD,
Yeah.
so you need that even other countries must invest in order to have a policy effect on your.
So there's an issue of integration, spillovers, and also openness, to some extent,
You can say if you take, for instance, low level of one variable, the z-axis is 0 fundamentally for all the value of the other variable. And so as you may say exactly what you say, the effect of the policy increase with both, almost linear in this case. But so it's a very interactive effect. Depends on both. So you need both.
No, if I may add, that's an interesting point, but I'm not sure you need cooperation in the sense that you might mimic the others. Now I go back to my view, obviously I fear, but what this seems to suggest is that the other R&D is important for you, but not necessarily through cooperation. You may simply see what they do and learn from the others, grasp the model you want to apply. Why not? I will give zero contribution. You know, the zero inflated.